wanted to address some issues with the empirical rule today. The empirical rule uses a standard bell-shaped distribution set up like the picture that we have here. The numbers at the bottom of the line represent how many standard deviations away from the center mean each line is. So for instance, at this bar of 1, that means that we are 1 standard deviation above the mean. 2 would be the mean plus 2 standard deviations, and then 3 would be the mean plus 3 standard deviations. That's 3 standard deviations above the mean. To the left side, when you do minus 1, that's 1 standard deviation below. We have 2 standard deviations below, and then 3 standard deviations below. So the mean is the average of the population that you're dealing with, and the standard deviation represents the spread. The empirical rule has set values or percentages that go with each standard deviation. The empirical rule says that 68% of your data fall within 1 standard deviation of the mean. If you take that 68% and split it in half, that means that you have 34% to the right or above the mean, and you have 34% below the mean. 2 standard deviations is 95% of your data. 95% of all of your data values are within 2 standard deviations. If you were to take 95% and subtract 68%, you would have 27. That means that in the outer regions here, that's 27% because I already have 68 in the middle. Well, if you cut 27 in half, you get 13.5. There's 13.5% in the bar from -2 to -1 standard deviations, and in the range from 1 to 2 standard deviations. And then finally, 99.7% of the data values fall within 3 standard deviations. I'm going to do the same thing. I'm going to take 99.7 and subtract 95, and I'm going to get 4.7. So there's 4.7 hanging out on the outside from 2 to 3 standard deviations. When I cut that in half, I get 2.35. So I have 2.35% of your data values from 2 to 3 standard deviations and from -3 to -2 standard deviations. If you happen upon a question that asks you, use the empirical rule to tell me the percentage of people that fall within a certain value. Let me give you a scenario. We have scores of an IQ test that have a bell-shaped distribution, and they have a mean of 100 and a standard deviation of 10. And then we want to use the empirical rule to determine the following. We have what is the percentage of IQ that score between 70 to 130. What is the percentage of people who have less than 90 and greater than 110? And then finally, what is the percentage of people who have a score greater than 110? The first thing that you want to do is you want to label your normal model and draw a picture. I draw this curve and then I label. Underneath the mean, I put what the mean is of the problem. And then standard deviation is 10. So 1 standard deviation above, I add 10 to 100 and I get 110. Add another standard deviation, I get 120. Add another standard deviation, I get 130. And then I take away a standard deviation as I go to the left. This would be 90, 80, and 70. And you can always fill in your normal model, regardless of the scenario, as long as you're dealing with a bell-shaped normal distribution, you start with the mean in the middle and then do a standard deviation above, standard deviation below to fill in your curve. So the first question asks me for data between 70 to 130. So 70 to 130 is this entire range here. And that entire range is 3 standard deviations from the left up to 3 standard deviations on the right. And notice at the top of my graph, I have 99.7%. So A, there is 99.7% of the population that fall between 70 to 130. For question B, I want to know less than 90 and greater than 110. I'm going to pick a different color here. Less than 90, I find 90 where I've labeled. That's to the left. And greater than 110. That's to the right. Now, one thing I didn't add is if I have 99.7% of the population contained in those 3 intervals, what's the leftover? Well, 100% minus 99.7 gives me 0.3%. Cutting 0.3% in half is 0.15% in the very tail end. And if you add up all of those percents that I've written in the middle for you, they will add up to 100. So less than 90. For B, I'm going to write out all of these values. Less than 90 is 0.15%, 2.35%, 13.5%, 13.5%, 2.35%, and 0.15%. It can also be seen as the complement of 68%. That's going to add up to 32%. Okay. I have my 27 plus my 4.7 plus my 0.3. It gives me 32%. And the last part of this question asks me for greater than 110%. So again, I'm going to pick a color. And greater than 110% is right here. That's 1 standard deviation or above. That gives me 13.5% plus 2.35% plus 0.15%. Which is a total of 16%. So what you can do here is you put the mean in the middle, label your standard deviations to the right and to the left, and then you can use your picture to help you answer these questions. I hope that was helpful for you. Have a great day.